This lesson is on the quadratic formula. The quadratic formula is another tool that is available for you to use when trying to figure out information about a quadratic relation. So far what we've seen is how to change from standard form to factored form or standard form to vertex form in order to solve or determine properties about a quadratic relation. Well, it's not always the case that you can factor something or factor a quadratic relation, and that's where the quadratic formula comes into play. For example, what I'm going to do actually is show an equation that's factorable and then show how to use the quadratic formula so that we can see that we're actually going to find out the same information, but then we're going to use the quadratic formula for something that's not factorable. All right, so for example, if I have the, helps if I select the pen. So, for example, if I have 0 equals x squared plus 6x plus 5, we have a quadratic relation, and what we want to do is find the x-intercept. So we're setting y to 0, that's where the x-intercepts are, find the zeros. So if I was going to factor this, I set up my chart, and I have my x squared here and my 5 here, and what I need to do is I need to find two numbers that will multiply to 5 and add to 6. Right, so we know that these two boxes here, they have to add to this middle term. And we also know that these two have to multiply to the same as these two. So we need to multiply to 5. 1 times 5 is 5. And add to 6. So if we look at that, that's multiplying to 5 is 1 and 5. And adding to 6 will be 1 plus 5 is 6. So we know that we would have, and it doesn't really matter, we have 1x here and 5x here. Common factoring each row and each column. Here's x, this would be 5, x, and this is 1. So my factors are, so I'd have x plus 1, x plus 5. Now solving, we're going to take each factor and we're going to set it to 0. And I end up with x equals minus 1 and x equals minus 5. Now, the quadratic formula, it's a long formula, it looks kind of awkward, and what it is that because here I'm trying to find out, again, what x is equal to, the value for x, that will make all of this equal to 0. So the quadratic formula looks like this. It is x equals minus b plus or minus the square root of b squared minus, that looks like a 6, so I'm going to erase that, plus or minus the square root of b squared, that's squared, minus 4ac, all divided by 2a. And what we do is we just substitute in values for a, b, and c into this formula. So here, if I look at the equation that I have, I know that a is equal to 1, b is equal to 6, and c is equal to 5. And I'm just going to take that information and I'm going to substitute it into this equation. All right, so I have x equals minus b, which is minus 6, plus or minus the square root of 6 squared minus 4 times 1 times 5, all divided by 2 times 1. So that is equal to minus 6 plus or minus the square root of 36 minus 4 times 1 is 4. 4 times 5 is minus 20, all divided by 2. And then I have that is equal to minus 6 plus or minus the square root of 16, all divided by 2. So now this is where I'm going to branch off, because we have either a positive square root of 16 or a negative square root of 16. So there's two possibilities. So I have two branches here. So with my two branches, I'm just going to move this up a bit. I have minus 6 minus the square root of 16, all divided by 2. And I have minus 6 plus the square root of 16, all divided by 2. And moving that up again, I have minus 6 minus 4, the square root of 16 is 4, divided by 2. And I have minus 6 plus 4, all divided by 2. And whoops, erase that. Just meant to move that up a bit. And then finally I will have minus 6 minus 4 is negative 10 divided by 2, and minus 6 plus 4 is negative 2 divided by 2. So finally I have minus 5 and I have minus 1. So x is equal to either minus 5 or it's equal to minus 1, and that's what we expect. We'd expect to see that because whether I use factoring to solve or whether I use the quadratic formula, I expect to see the same thing, because all we're doing is solving the same equation but just doing it in a different way. Now for some of you, you'll think, ooh, right on, I now know the quadratic formula, I will never have to factor again. And that is, I guess, essentially true, but the thing is that we use the quadratic formula only when we can't factor. And the reason is that students often make mistakes, and the other when we talk about efficiency. It was much more efficient, I'm just going to move this down again. Look at the number of steps to factor and to use the quadratic formula. Using the quadratic formula, there was a lot more steps and a lot more situations where you can run into mistakes. I will point those out as I go through and show some other examples. So this is solving by factoring, this is solving by using the quadratic formula. And I'm not saying don't ever use a quadratic formula, because you will absolutely have to use it, but the difference is that a lot less mistakes happen here. It's a lot more efficient, a lot less steps. Here, there are some pitfalls that students run into and often make mistakes. And I will point those out as we go through more examples. All right, so let's start with an example here. So if I have, trying to solve this, so 0 equals 2x squared minus 3x minus 7. So here I'm trying to find the x-intercepts or the zeros. The first thing you should always try is to see if you can factor it, because you can factor it, great. If not, we're going to use the quadratic formula. So if I'm going to set up my chart, I have 2x squared and minus 7. So I know that to fill in my chart, I have to, these two have to add to the middle term, and these two also have to multiply to the same thing as these two. So 2x squared, so 2 times negative 7 is minus 14. So we need two numbers that will multiply to minus 14 and add to negative 3. Alrighty, so my factors of negative 14 are negative 2 and 7, and when I add those together, that does not equal negative 3. That Those add to 5, so that doesn't work. Then I have 2 and minus 7, and that gives us negative 5, so that doesn't work. We have minus 1 and 14. That should be an and. I'm going to erase that. I'm going to actually erase all of that. So minus 1 and 14. If I add those together, I get 13. And if I have 1 and minus 14, I get negative 13, which is still not negative 3. So none of these work. And so I know that this is not factorable. So now what I need to do is, okay, well, now I'm going to try the quadratic formula. The quadratic formula will help me determine what the roots are, if there are any. Okay, so quadratic formula, I'm going to separate these off here. Okay, so now I'm going to use the quadratic formula, which is x, I'm trying to find the x-intercepts, is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Common mistakes: students not extending this all the way over to the negative b. Please make sure you do that. Okay. The other common mistake is not identifying what a, b, and c are. I see many times students actually write in the wrong values for a, b, and c, so please make sure you write them out before you enter the, or put them into the formula. So we know that a is equal to 2, b is equal to negative 3, and c is equal to negative 7. Alrighty. So I have x is equal to minus b, which is minus 3. That's minus. Plus or minus the square root of b squared, which is minus 3 all squared, minus 4 times 2 times minus 7. And that has to extend across, all divided by 2 times 2. All right, that is equal to minus 3 is 3, plus or minus the square root of 9. Minus 4 times 2 is minus 8. Minus 8 times minus 7 is minus 56. Sorry, it's plus 56. All divided by 4. This is a 9. Alrighty. So then we have 3 plus or minus the square root of 9 plus 56 is 65 divided by 4. So now I have my two branches. So I have x is equal to 3 plus the root of 65 over 4, and 3 minus the root of 65, all divided by 4. So I'm just going to move this up slightly. So if we want to look at things, this is actually where we can write, this is the exact answer, because 65 is not a perfect square. There's no perfect square root of 65. So these two are the exact answers. If we want to find an approximate answer, then we will evaluate for what the square root of 65 is. All right, so we have, whoopsie, x equals 3 plus, and the square root of 65 is 8.0623. I'm going to divide all of that by 4. And I also have the other option of 3 minus 8.0623, all divided by 4. Moving this up, I have x equals 2. I'm going to say it's 765, so 7, 7, and or x is equal to negative 1.27. So we know that there are two x-intercepts. There's one at x is equal to 2.7 and x is equal to 1.27. Okay, so what I'm going to do is I'm going to, on the next slide, I'm going to put an example where I would like you to go through and try this on your own, and then we'll take it up. Okay, so I'd like you to solve this. Oops, should pick the pen. 0 equals minus 3x squared plus 5x minus 1. So try that on your own. Don't forget to try to factor it first, and then we will take it up. Alrighty, so we're back. So here we go. So we're going to try to factor this. I'm going to set up my chart. So I have 3x squared in that box. I have minus 1 in the other box, and so what I need to do is, we know that these two have to add to 5, and they also have to multiply to negative 3, because those are this, it has to multiply to the same that these multiply to. Alright, so they have to multiply to minus 3, or sorry, plus 3. That's a negative 3. And they have to add to 5. And so that's impossible, because the only factors of 3 are 3 and 1, and negative 3, negative 1, so 3 and 1. So if I have 3 and 1, those add to 4, so that's not going to work, and negative 3 and negative 1 are going to add to negative 4, so those, neither of those work, so it's not factorable. So let's use the quadratic formula. So I have x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Again, writing out what a, b, and c are. A is equal to negative 3, b is equal to 5, and c is equal to negative 1. So I have x is equal to minus b, which is minus 5, plus or minus the square root of b squared, which is 5 all squared, minus 4, times a, which is negative 3, times c, which is negative 1, all divided by 2 times negative 3. Alright, so that is equal to minus 5 plus or minus the square root of 25. And then minus 4 times minus 3 is positive 12. Positive 12 times negative 1 is negative 12, so minus 12. All divided by 2 times negative 3 is negative 6. I'm going to bring this up here. And so now I have x is equal to minus 5 plus or minus the square root of 25 minus 12, which is 13, all divided by negative 6. Alright, so again, as I mentioned before, this is the exact value, okay? So this is the exact. So there's 2. Minus 5 plus the root of 13, all divided by negative 6, and minus 5 minus the root of 13, all divided by negative 6. So there's those two possibilities. That's the exact value. Now to find the approximate value, we're actually going to go through and solve these. So we have two branches. And so I have x equals minus 5 plus the root of 13, all divided by minus 6. And I have x equals minus 5 minus the root of 13. That's a 13. All divided by negative 6. So That will give me 0.2324, so 0.23, whoopsie, 0.23, and the other will give me 1.4343, so let's go with 1.43. All right, so those are our two x-intercepts. So this is where we can use, again, the quadratic formula in order to find out what the x-intercepts are. What we're going to do next is we're going to look at how we can use the quadratic formula to actually determine whether or not there are any x-intercepts, because it may not be the case that a quadratic relation actually has x-intercepts. Okay, so let's try to solve this one. So we have 0 equals x squared minus 2x plus 13. And what we're first going to do is we're going to see if we can factor this. And so when I make my chart, again, I know what x squared goes there, and 13 goes here. The two that fill in these two boxes, the two terms that fill in here, they have to add to -2, and they also have to multiply to 13, because 1 times 13 is 13. So we're going to check to see if they multiply to 13 and add to -2. So multiplying to 13, well, there's only two possible factors. There's 13 and 1. And there's -13 and -1. So 13 and 1 and -13 and -1, and neither of those will add up to -2. And so we know that it's not factorable. Now let's check to see if we can actually solve this using the quadratic formula. So I have x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And I know that a is equal to 1, b is equal to -2, and c is equal to 13. All right, substituting in, I have x equals minus, and b is equal to -2, so I'm going to put that in brackets, so minus -2, plus or minus the square root of b, which is, b squared, which is -2, all squared, minus 4 times a, which is 1, times c, which is 13. And that is all going to be divided by 2 times 1. Then I have x equals minus -2. This is one of those common mistakes, the minus -2. Students will drop one of these two negatives and continue to let it be negative, but it's not. It is now positive, so I now have minus -2, which is 2. That's I'm not going to the store, so I am going to the store. Plus or minus the square root. -2 all squared is 4. I just want to say that the brackets are very important. This is implying that I am squaring -2. So I have -2 times -2. That is different than if I had no brackets there. If I had no brackets there, the result would actually be -4. And that has to do with Bedmaster rules. So you have to be very careful when you're plugging that into your calculator that you keep the brackets around the -2. Otherwise, your calculator is going to tell you that it is -4, which is not true. All right, so then I have -2 times -2, which is 4, minus, and then I have 4. -4 times 1 is -4. -4 times 13 is -52, so minus 52. And that is all divided by 2. Bringing that up here, I have x equals 2 plus or minus the square root, and 4 minus 52 is minus 48, all divided by 2. All right, so we've got a problem because you cannot take the square root of a negative number. It's impossible. So what this tells us, because we cannot take the square root of a negative number, just like when you're using, when you're solving from vertex form, if you end up with a negative under the square root sign, it means there are no x-intercepts. So in fact, this is where we stop. We can't go any further. Stop. There are, since we cannot take the square root of a negative number, there are no roots. Okay, or x-intercepts, you know, slash x-intercepts. So that's a really important thing to know. What happens is that actually this part here of the quadratic formula, the square root, or b squared minus 4ac, is known as the discriminant. And because it can tell you how many roots or how many x-intercepts there will be. If, when we look at these, the b squared minus 4ac, if this happens to be negative, such as in this case, then we know that there are no x-intercepts. If it happens to be positive, b squared minus 4ac is positive, as in the previous examples, then we know we can take the square root, and we have a plus or minus square root, so we have two possibilities, or two possible x-intercepts. Now, if all of this adds up to 0, we actually know that we only have one x-intercept. And that's because the square root of 0 is 0. And so that's how we can tell how many x-intercepts there are. So I'm going to write that down on the next slide. All right, so again, whoopsie, got to select the pen. B squared minus 4ac, this is known as the discriminant. And the discriminant can tell us useful information about a quadratic relation. So if b squared minus 4ac is greater than 0, I'm going to say greater than 0, then we have two roots, or two x-intercepts. If b squared minus 4ac is equal to 0, then we only have, I'm going to erase that and use the letter or number like I did in the other, one root. So one x-intercept. And, or if b squared minus 4ac is less than 0, so less than 0, we have 0 roots. Okay, 0 x-intercepts are the same thing. And that's because you cannot take the square root of a negative number. All right, so remember that. You cannot take the square root of a negative number. And so that's how this the discriminant can be useful in trying to actually figure out if how many x-intercepts you actually have.